Hello, this will be a quick video on finding the derivative of root x using the limit definition. So first, let's find f of x plus h. Since f of x is root x, f of x plus h will be root x plus h. Wherever we see x, we replace it with x plus h. So let's actually write out the formula. So it'll be the limit as h approaches 0 of f of x plus h minus f of x over h. Now it doesn't seem like we can do much, but we can actually multiply by the conjugate. And I'll explain that real quick if you don't know what that is. If you have a plus b, our conjugate will be a minus b. And vice versa. If you have a minus b, our conjugate is a plus b. So why is that important? Well, if you multiply by the conjugate, we can actually FOIL this out. So a squared plus ab minus ab minus b squared. Middle terms cancel out. You get a squared minus b squared. So if you multiply by the conjugate, you'll get the difference of two squares. And that will actually come in handy for us in this particular problem. So let me move this so we could reference it. So the main lesson here is that if you have a, b, the conjugate will be the same, a, b. You just flip the sign in the middle. So we'll keep the terms the same. Root x plus h, root x. Let's multiply the denominator by the same thing. And then we just flip the sign of what we had before. Since we had a minus, we'll just put a plus and a plus. So let me start with the denominator. I won't distribute the h. I'll just keep it as is. Now for the numerator. So we can FOIL this out, but we already know on the right hand side it'll just be each term squared, and we just put a minus in between. So we'll have x plus h squared, a minus in between, and then root x squared. And this will always be the case if you multiply by the conjugate, which is why we use it, which is why it's helpful in this problem. So let's continue on. Radical x plus h squared. The square and the radical cancel out. That'll give us x plus h. And same thing with root x squared. That will cancel out, give us x. And then we still have our denominator. Alright, so let's see if we can combine any like terms. Looks like we can. The x and the minus x combine and cancel out. So we're just left with h over h, root x plus h, plus root x. And then as you can see here, the h's will cancel out. That'll be 1 over root x plus h plus root x. Now this is a limit, so let's actually apply the limit. Let me rewrite this first actually. So 1 over root x plus h plus root x. And now we can use direct substitution. We can just put in 0 for h. So we'll have x plus 0 plus root x, or 1 over root x plus root x. Now these are like terms, they're both root x's, and we have 2 root x's, so we'll write just that, 2 root x. And that is our derivative. That's our final answer for this problem, and thank you for watching.